In this video, I want to give the briefest of introductions to MASH. So MASH is a procedural animation, motion graphics, object distributing tool. And I think it's fantastic. It's one of the best additions to Maya in a long time, particularly for the type of work I do, doing biomedical animation. We often have to have populations of things, proteins, molecules, or things distributed on other things, so cell membrane proteins and that sort of stuff. And in the past we'd have to use particles for that, which we still can, and that has a lot of benefits. But a lot of the time you can get away with using MASH, and it's much more responsive. It's easier to iterate and make small changes. And it's usually more than enough for what we need. But anyway, so with that out of the way, let's just look at what MASH does. So it's under the FX menu. And if we select an object, and usually if it's a population of small things you're not really going to see, you can just use a cube or something. It can be any type of model though. We'll go to MASH and we'll create a MASH network. And we can either create an instance network or a mesh network. The difference being is that an instancer network will be much lighter on the machine because it's actually not making duplicates of the shape node, it's just making duplicates of the transform node. So you'll have a single shape node and it will be spread around the scene or doing whatever just based on different coordinates for transformations, so translation, rotation, and scale. But it all depends, it's all linked to a single shape node, whereas a mesh network will actually make a duplicate of the base mesh. So if you have 1,000 cubes in the scene, you have to have 1,000 shape nodes. If you have the instancer network, if you have 1,000 duplicates in the scene, you'll have one shape node and 1,000 transformations added to it on the instances. And so why would you choose one over the other? Well, the main difference with the mesh is that you can change the color of the duplicates on a case-by-case basis using procedural methods. You cannot do that with the instancer. You may also want to make lots of duplicates of this and then duplicate that whole set of things into a new shape, and you need the mesh node for that. Most of the time, instancer is going to be the better choice. You have to change the color. If you want to duplicate the whole thing and take it out of the MASH network, then mesh is probably better. There are probably other things to do, but I don't know. So the network name by default is going to be called MASH 1, 2, 3, or 4, whatever. I can name it on creation. I usually leave this as is, but you can change the name there if you want. So I'll just say apply and close, and you can see that it makes 10 duplicates of my cube. Now the original cube is not there anymore. It's hidden, so you can see it's faded out here in the outliner, and these are all instances of that cube. That means if I make a change to this original cube, like if I scale it, then these will all scale too. Scale it down, make them smaller, but I'll just leave it as is. And so if we want to, if I make changes to the shader on this thing, then these should also change? No? Maybe not. Okay. I thought that would work, but maybe not. Okay, so if we go here, we see a couple of things are created. A MASH library, or no, it's called the MASH waiter. You've got an instancer, which lists the object that's being instanced here. The MASH waiter has all the different MASH nodes you can add. And then by default, a MASH distribute node is created. And so this is the first place to start. So there are different ways to distribute these objects, either linearly, which we're seeing now, and we can add a number of copies in there, and we can change the distance in X, Y, and Z. You can have them scale up with each version. You can do this sort of thing. You can also rotate them. All these things could be animated, but there are different ways to add animation here. So let me just zero these things out again. There, so we're kind of back to normal. Oh, something is weird with the scale. 1, 1, 1, 1. Oh, it should be 0. So we don't want anything added to the scale. Okay, so that's linear. You can center the distribution. Radial, same sort of thing, but it's got a new menu set here. So the radius, the angle, so how far along is the offset, so you can make sort of a spiral, right? Change the radial axis, and then the number of points can be changed up here again. Spherical, it tries to place it along around the edges of an invisible sphere, as you can kind of see here. If we increase the numbers, so I can go to say 5,000, and it's coating almost the entire surface, but you can see what it's trying to do there. You can change how much of the sphere is covered, so you get the angle here, the radius of the sphere. This can be animated, so having them move around the surface, but you'd have to key the animation time, so we can go back and set a key here and then change this slightly and set another key, so you can get animation that way. We can change this to a grid, and this is useful. So here to grid, so change the size of the grid. And here we don't change the number of points up here, but we change in the grid settings how many points there are, because you have to do it in 3 dimensions now. Okay. Now let's just reduce our count a bit so we can see what's going on a little bit more. And so you can see how responsive this is. If you wanted to do something like this with particles, it would be quite difficult. So now if we... There are a couple other settings. There's mesh, there's paint effects, and there's a placement one. We'll come to these later. Let's leave it at grid for now and then go back to the mesh waiter. So this is how you can add other effects. And I'm not going to go through all of these because I'm not set up and I haven't used them, but audio, you can link this to an audio track so they can react, they can scale up in time to the beat, scale down, things like that. You can have them follow a curve, and this is a more involved process, so we'll talk about this in another video. You can add delay, so we'll look at this later. This comes sort of after you do other things. Flight is a very interesting one. It's sort of a pretty good crowd simulation sort of thing, or swarming, doing boids, or like birds flocking and things like that. ID is a specialized one for adding more than a single object in a distribution. But some of the important ones that you'll use quite a bit could be random. So if you just click on it and say add random node, so you can add randomness to the position, right? To the rotation, so you can distribute these in your scene, and even to the scale. You can do a uniform scale, just changing one, it'll change all 3 axes. But this does not animate. You can change the random seed, so it just multiplies this out. Now all of these effects will have strength settings, so you can use these to animate it going from state to state. So the overall strength, you can go from 0 to 1, you can animate this, having them achieve that position. Random strength, oops, I have to put strength back up. So random strength does sort of the same thing, but instead of doing it in a predefined order, it will choose randomly which ones to move when. So in this case, you're not going to see a huge difference, but the strength one does it in a more orderly fashion. And then step strength does it in totally orderly fashion and does it one at a time in order. Strength does it from the center out, I think. This one does it row by row, column by column sort of thing. And you can map things here. You can do all sorts of stuff. Another important thing that you can do in MASH, and this is one of the most useful things, is using a Falloff object. So if you open up the Falloff object and right click and say create, it creates this little sphere here, and it's got an outer radius and an inner radius, and there's a fall off between these two, and the full effect of the in this case the random node will only be felt when the objects are within the central area, but they'll gradually approach that as they move closer from the outer edge to the inner edge. So you can animate something like this going through. You can see when they exit that volume, they go back to their original state. So this could be useful. You could attach this to another object that's animated through these things, so it seems like they react to its passage and so on. This thing has its own node. You can see it's in the outline here, but if you double click on the name here, it will take you into that node, and you can change it from a sphere to a cube. You can have a NURBS curve. You can use particles, which I talk about in another video, or you can use a whole other mesh. So you could assign this to a mesh. So if you did that, it would give you an option of assigning a mesh in the shape in here, which we don't have right now. So let's go back to sphere. Another important part here is the mode. So the normal mode means that the effect is only felt while it's in that place, so it's transient. If you change this to add and you go through, it pushes them into a position and then leaves them there. Go back to normal, then it goes back. Okay, so these are great. You can play around with these. There's a fall off you can change the size of the inner zone. You can just scale up the whole thing. You know, if you need a bigger object, then you can do that. So let's make a little animation here. We'll just keyframe this thing moving, so we want to do it in the Z direction, so I'll just set a key on that, and then let's say over 120 frames it goes through here, right? I think I might be on play every frame. Go back to real time. So that's the other great thing about this. This is a real-time thing. You don't have to solve this like you do particles that have to solve on every frame. You can play it back in real time. So that's a little slow. So I'm going to, in the timeline, if I hold down Shift and drag over a keyframe, I can then grab this whole red area and move it. Just make this a little faster. So let's add a couple of other nodes here. Go back to the MASH library in the attribute editor, and we've got this spring node. So if we add this now, and this will add some secondary motion to this animation. Now let's see if it works right off the bat. See how they kind of bounce back before they settle into place? Nice, right? So we can change this to have less stiffness, less damping. So we can see it a little more. So imagine like an object going through suspended particles in a fluid or something, and you want it to have sort of a wake. Like it reacts to it and then they settle back into place. The spring can be great for that. So let's say we want to get rid of some of these nodes, right? So we can do this in a couple of ways. So we go back to the random node, for example, you'll see there's a delete attribute, and we can just say delete this node. Yes, we want to delete that. We're not seeing any of the randomness now because it's outside of the Falloff object. And then we can also go in and we can find the spring and delete that there. The other way to delete things, so let me just put that random back on. And there's another way to view these different nodes that are applied. If we go to Mash Editor, there's a thing sort of like the outliner here that shows the order of operations here. So we've got our distribute, then we've got our random. There's an on and off switch if you want to just hide the effect but not delete it. Or you can right click and just say delete here. So I want to get rid of this random. Okay, good. So now I can either go into the Mash Waiter, or I can actually add an effect here in the Mash Editor. So here I want to add a signal node. So signal is like an animated random, essentially. So right now what's being randomly animated is the position in Y. So you can see that this Falloff node isn't doing anything anymore, so I can just delete that out of the scene. Right, and because this is procedural, you can make changes to all of these things to change the nature of the animation. And you can add it to rotation as well if you want to, let's say. And to scale or whatever. So there's nothing keeping these things from bumping into each other, which is something you could do to a certain extent with particles. And so that's one of the limitations here. But in a lot of cases, that doesn't really matter. Just turn that scale off. So in the signal, you've got things like different types of noise, transformation space, just leave that at world. And then you can change the different settings depending on what type of noise that you're using here. So if we turn up the time scale, that will make the animation go faster. Turn it down to a very low value, then we'll just get a much more subtle animation. Step amount will sort of influence how far these things will go. Let me turn this up. You can change the scale of the noise, so how much internal noise there is in the noise, and so on. You still have all the strength settings, so you can animate going from off to on. So here, only those ones will move, and I can change that. So when I turn off enable step, it makes it much more like a wave pattern. It's kind of hard to see unless we go into distribute and maybe increase our numbers. Right? So now if we play this, you can see it. Now these ones aren't going to pass through each other because there's no internal sort of sub noise in here. It's just a big wave that's going through it. If I go through and go back to the signal and enable step, then each one is considered differently and they can pass through each other. So I just invite you to experiment with this. Looping noise, I don't even know what that does. Interesting. Fractal Brownian motion. Sounds molecular. Okay, that's with stepping turned off. That looks exactly the same. So this is also reacting to the noise and persistence here. Huh, that's interesting. Trigonometry. Sounds mathy. Whoa. See if we can see what's going on here. I'm going to turn down my number. So anyway, that's kind of interesting. You can play around with these things to do what you want. And this would also work with spring. There are lots of different things you can do, and you can, change the offset in something. So if we want to offset the position of all of them, so up 1 in Y, for example, but then you can adjust the random strength so you can have them move up 1 unit in Y. You can change this to 10 to make it more obvious. If you need to animate something like that, so you can do it for scale too. Anyway, so there are lots of things you can do now. Without going on any more than this, one very useful one that I found is the transform one. So if you go here, you can go to transform. If you want to move this entire mesh network to a different point in the scene, you can add a transform node, and let's say it has to go up 20 in Y over 5 in X. And so that can be useful, but a more useful way of using this tool is to add a locator into the scene. You can put it sort of in the middle here. And now we can look at the transform node, and it says controller null, and it accepts the transform. So a locator in Maya is just an empty transform with a visual representation in the scene. So I can just middle mouse drag that locator into here, and now wherever I move this locator, the whole network will also move, but we can still, the signal thing will still work over there. It's just a way to move it around the scene. Anyway, this is really just touching the surface of what MASH can do. I'd invite you to look at the Mainframe North Vimeo or YouTube channel, the creators of MASH, before Autodesk bought them up, I guess, or however that works. And Ian Waters is I guess one of the main creators of MASH, or at least the guy who does all the demonstrations of it. And he demonstrates amazing stuff on YouTube and in Vimeo, so look up his stuff too. And you can see some of the amazing things that you can do with this. I'll have more MASH videos after this, but this just gives you a basic idea of what it can do.